Okay guys, so I'm hoping this video doesn't take too long. It's pretty straightforward. There's only one thing I'd really like you to see. Page 726 is where I wanted you to start today. Let's investigate the effect of an equation like with graph shifts. This is also vertex form, but we're talking specifically in this lesson about graph shifts. So I'm just gonna think of those where A is a positive number. So this looks awful. It just means A is positive because a number bigger than 0 is positive, which means it's happy. Where A is positive, parabola is happy, and D is positive. So wait a minute. If A being positive makes it upward facing, what does D being positive mean? Because if D is greater than 0, it's positive, and that's that number. So what happens when you're plus a positive number? Well, my goodness, it means you go up. So in this case, we're talking specifically about parabolas that are upward facing that go up. Let's consider this specific graph. So the 5 doesn't matter in this case, but we do have a positive number for A, it's upward facing, and it's shifted up. Take a look at this. Are there any x-intercepts? So remembering that we can solve from just our eyeballs if we have the graph. So we're working on solving for x. This is our #1 intention for the end of the year. And one way to solve for x with no equation, so we could use the equation, is to use our eyeballs. Well, there's no x-intercepts. So none? Are there no x-intercepts? So right here, there are no zeros, but I want you to know for your future in Math 3, which I might have you next year. I have 3 sections of Math 3 next year, so you could be in my class. That every time you have 2 x's or an x squared, like this, you have all hopefully been working on solving this and getting 2 answers. So in Math 3, you're gonna learn that if you have x squared, you need 2 answers for x. There's always gonna be 2 roots. If you have x to the 3rd, could you guess, you're actually always gonna have 3 options for x. Same with x to the 4th, etc., etc. You're gonna have as many x roots as there are for each of these values. These are all different polynomials, but we're focusing on this one because we are in Math 2 and we just care about quadratics. Quadratics are the key. And so we're gonna solve for these 2 x values like we have been. Now, I'm hoping you did this page 724, solving for x. If you need me to do these for you on a different video, just email me and I will make a second video today. But you should be solving for x like this that I'm about to show you. You're isolating x. So we're gonna take this and see what happens when we try it algebraically. Eyeballs tell us there are none. Let's see what math tells us. So I am going to isolate x by subtracting 1 on both sides. Okay, 0 minus 1, -1, bring everything else down. Now, I'm trying to isolate this x by doing the inverse of PEMDAS. So before I get rid of the squared, I'm gonna divide by 2 to get rid of that 2. Hopefully you've been remembering to do that. Divide by 2 first if there's a number multiplying in the front. So now I have -1.5 or -0.5 if you'd rather write that. That's just division as our fraction. We bring down x minus 5 squared. And now to get rid of the squared, we've been square rooting both sides. I don't know what's wrong with me. Square rooting both sides. So now if I bring this down, I have the square root of -1/2 or -0.05 equals x minus 5 plus or minus. So remembering that when you square root something, you actually have 2 answers. Here is the key here that we've been working on. You are going to have a positive x minus 5 as one of your answers, because when you square root something, this whole inside could be positive or the whole inside could be negative. Now, I again would like to ask you, if this is uncomfortable, please let me know how you did on these ones, because there should always be 2 answers. When you take the square root to cancel this out, for example, square rooting both sides means you're going to have positive x minus 4 equals 2 and negative x minus 4 equals 2. Yes, you have to distribute here. Okay, there's my long pause to remind you that that's important. Okay, so for this one, we have the square root of negative 1/2. The square root of negative, I'm going to put 0.5 and ask that you guys do this in the calculator. If you already did this today, what happens when you put in a negative number to a calculator? The answer is that is impossible. Negative numbers inside of a square root, negative anything, negative 4, that's impossible. So you guys know nothing. You can't do it. So you guys know that the square root of 4 is 2, but the square root of negative 4 is impossible because 2 times 2 is positive 4. Negative 2 times negative 2 is positive 4. You're never gonna, there's no number that you can multiply by itself that will get you a negative. Like, I dare you right now, come up with a number that if you multiply it by itself, you get negative 4. Because that's what this operation means. They ain't nothing. Can't do it. So it says, while there are no real zeros in this function, there is another type of zero you'll learn about later. So the reason this is impossible still means that these are the answers, but this, anytime you have a negative number, this is actually an imaginary number. And that's why it tells you there will be something later to help you like describe that this is not going to be 2, but it's an imaginary 2. It's not real. There's no real number that will work for this, but mathematicians made up an imaginary number so that it would be possible. So for these, I just want you to finish by doing some graph shifts. So I will do the first one with you. If you think you're good at graph shifts, then you're fine. I need to know that this means I move the vertex right 2. This means I move the vertex up 4, so I'm going to start there. Instead of at 0, 0, I'm going to go shift right 2, up 4, and that is my vertex. So is this a happy parabola or a sad parabola? Well, the parabola is negative as its a value. A is negative 3, so I know I'm going to go down to make a sad parabola. But a reminder that this 3 means that instead of going the slope over 1, down 1, or over 1, down 1 to make my curve, I'm actually going to go over 1, down 3. 1, 2, 3. Over 1, down 3. 1, 2, 3. And this is going to be a very skinny parabola. That's good enough. If you'd like to check Desmos and find some other points down here, you may. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is where the point is supposed to be. And there's a symmetric point, so it's over 2. So I'm going to go over 2. So I didn't do a great job with my line. It's a little too straight. It should be curvier. But that's how you do that. And after each of these, it asks you to interpret on the graph in terms of the axis of symmetry and the points on the parabola. So here we see that our zeros, our axis of symmetry is x equals 2, that line. So I kind of dotted it, but this line, x equals 2. And then it says we are supposed to be figuring out where the zeros are. So these are real numbers. Do you guys see here that where it crosses the x-axis is not on a whole number though? So I'm going to say there are 2 real x-intercepts. And I'm using the word real here, and that's an actual math word, meaning it does cross through the x-axis. This one did not. This one does. So our eyeball check is that it does have 2, but I don't know what they are. They're decimals. So maybe I'll write they're decimals though. So I don't expect you guys to come up with this number with your eyeballs, but you could do it if you solved this with algebra and you set it equal to 0. You could find the decimals, but your eyeballs can't do it. So I'm going to say if you want a challenge, you can find the numbers using algebra, but you don't have to for this. We're just going to use our eyeballs and say, I know they exist, but they're decimals. I don't know. For this one, we got some graph shifts. We have a graph shift here I'm just going to test you first. You should know where this is. X plus 5 in the parentheses means left 5. So I'm going to go over left 5, and then plus 2 means go up 2. This is my vertex. Now, question, do my parabola go up or down? Well, my A value is positive, so it is going to be a happy parabola, but it's actually just going to be a little bit wider than usual. So 1 over 4, actually that width is pretty large, which means instead of going over 1, up 1, and making it a normal parabola, I have to go over 4, up 1. So rise 1, run 4, 3, 4. And then my symmetric point on the other side is the same. I'm going to go rise over run, up 1 over 1, 2, 3, 4. And that is my width. That's a big, wide parabola. So, does this one have x-intercepts? Eyeballs. No, it does not. Because it shifted up and it's a positive parabola, the parabola moved up, it's never going to cross that x-axis. So the same thing happens if you have a sad parabola and you move it down. If it never crosses through the x-axis, you say no real roots. So there are no x-intercepts, which means the roots are imaginary. There are no real roots. So I know I told you roots is a synonym for x-intercepts, and it's a synonym for solutions. There is no solution, there is no x-intercept, and there's no real root. Mathematicians came up with a way to still find the imaginary roots, but you'll learn that later. So I would say you don't need to do this. This would be really cool if you did the assignment page for today. This should get you through the class period. So I'm going to post notes that you can decide to take. They're more than tiny notes, they're a little bit bigger, but take some notes after you're finished with a few of these. Just decide, sketch a graph based on graph shifts, determine the zeros of each function. So are there zeros? If you don't know how to find them with your eyeballs, you can find them with math, but just try your best on this. If you need help, you can always go to livehint.com. Remembering this QR code will help you, but remembering that this is only an option for the assignment page. I'm not gonna make you turn this in. But yeah, enjoy. Email me if you have any questions.